Hello students, welcome to Learn and Practice, the Institute for Complete Learning, and here it is the class 10th chemistry's first chapter, chemical reaction and chemical equation and reaction. This chapter we are going to discuss. Okay, first of all we know that first of all I'm welcoming you all, and we know that chemical equation and reaction we have already done in class 9 for a few, but here the detailed in form we will read in this topic. The first here when we will introduce this topic, at that very time we have to understand that primarily what type of equations we did. First time we did, or primarily we did two type of equations, that is the physical equation and that is the chemical equation. Okay, physical equation means where the equations has happened and normally the product that comes, it can change again into reactants. It means these two products, suppose H2 plus O2 equal to H2O, and H2O can be reversed again. Okay, a reversible equation. In a reversible equation it can happen, but now what we are going to discuss, it is totally irreversible. Okay, it doesn't, or it never reverse anytime. It means the chemical equation is such type of equations where the products are used and they are joined together, or they are mingled together and make a new product, and that new product never reverse itself into the previous reactants. Got it? So how is it happened and what are called reactants? I am telling reactants, product, reactant products, what are these mainly we have to read. So let's start this chapter from the primary part. The first topic, it is about the reactants. What are called reactants? Reactant means suppose two or three or more than two or three things or the chemicals when I am using, and if these things are used for reacts together, those are called as reactants. Okay, so it means the chemicals, those which are used in the equation, those which are used in the reaction are called reactants. Got it? Suppose if I take here Ag plus Cl. Okay, so Ag and Cl I am using 2Ag and Cl2, Ag2 and Cl2. It means silver and chlorine. Two chemicals I have taken, now I am adjoining these two to make a new product. Got it? That's why these two products are known as the reactants. These two chemicals are known as the reactants. Now come to products. Products means we always know that it is known to us that when any factory manufacture anything, that's called a product of that factory. So the same way, when these two chemicals are adjoining together anyhow with the heat or with the help of heat or anything else by any medium, and it makes a product just like 2AgCl. I am balancing here 2AgCl means AgCl, this product, okay, silver chloride, this product has made, so a new product, a new thing has made with only the help of these two reactants. That's why it is called a product, and this product can never be changed or reversed again as a reactants. Got it? In chemical reactions or chemical equation it doesn't happen anytime, but in physical equation or physical reaction it happens. Next, now come to skeletal reaction. Another topic is same. Okay, before seeing the chemical skeletal reaction, let's go for that based what states can we deserve when a new product used to occur. Okay, so we can say here change of states. Change of states. What type of change can be seen in the product? Number of its color. The color can be changed. It means Ag and Cl, both chemicals colors are different to each other. Okay, and when they are making the product's color is also totally different of its reactants, and this color only has been changed when both of them have reacted to each other. Got it? So it means the color can be changed. Number 2, properties or the states. In your book states is written. It means the property of the product can be changed. The property that the daughter product that has produced, this property and those two reactants property can never be same. Can never be same. Okay, it will be totally changed. Number 3, color has completed, then property has color property it is completed, and then we can go for its temperature. temperature, it means the product that has brought or that has produced, it may bring temperature or it may produce temperature, or it may produce a very less temperature, or it may remain as a room temperature. It means temperature also it depends. And the fourth one is gas. When the new product is occurring, along with it as a byproduct, any gas can be formed, any gas cannot be formed. It means suppose any product has formed and along with it the byproduct hydrogen gas. Hydrogen gas has occurred and it has goes out as a gas. Oxygen gas has occurred, it just goes out. Carbon dioxide, it just goes out. So in this manner, any type of gas can be produced. Got it? I am not telling particularly for this reaction, but for every type of reaction, any type of reaction, whatever you want to do in the lab. Okay, somehow these states can be varied. Got it? Now, when the change of states has varied, now we can easily come to the skeletal reaction. First of all, reaction. We have to go for the reaction. Okay, let's go for it. So I am taking here Fe plus O2, Fe2O3, Fe2O3. Okay, so I am doing here 2Fe, okay, 2O2, 2Fe plus 2O2 equal to 2Fe2O3 because I have made it balanced. Look, at the first time in the reaction, no balance were there. Just I used here iron. We know that iron, it can be said as ferric or ferrous according to its number of molecules, number of atoms. Then O2 means oxygen. So these two as reactants I have used, and here only one product came, that is Fe2O3. So you can easily say that here Fe, only how many atoms are there? Only one atom. Got it? Because here nothing means one is present, so one atom is here. Here how many Fe are there? Two atoms. Look, before when it was reactant, that time only one. After reaction, two it becomes. Then oxygen, two molecules, two atoms were there. Here it becomes three. So it means the change can be, I have told you, the state can be changed, the properties can be changed. Here it has changed its property, means only one atom, only two atoms, it has changes two atoms and three atoms. Got it? So in this way, the reaction, by the reaction process, the state can be changed. Got it? For that purpose, when I will leave in this manner and I will not do anything, so such type of equation is known as the skeletal equation. Skeletal equation means the equation whereas the equation is completed but balancing is not completed. It is unbalanced. It is unbalanced because no balance has done according to its number of atoms. Got it? It is called the skeletal reaction. Now, how can I convert the skeletal reaction into balanced reaction? Balanced reaction, by this word easily we can understand that balanced reaction means the reaction that has totally balanced. That is right now it is balanced. Okay, so easily I can do in the previous way. So 2Fe, Fe2 means 2Fe, Fe is completed. Now here is 3, but here if I give 3, 3 2s are 6, but here is only 3. So if I give here 2, so 2 2s are 4, 4 Fe. So I can write here 4 Fe, 3 to the 6 number of oxygen, 3 to the 6 number of oxygen. Look, it has made a proper balance. Now I can say it's a balanced reaction. Okay, balanced reaction, skeletal reaction, any problem? Okay, fine. So reactants means we have got the chemicals, those which are going to react are called reactants. Product after reacting using the reactants, the product used to occur, and products have the same different type of states into itself. Mixed skeletal reaction, when they are going for the reactants as a reactant and they are going for a reaction. So what type of equation can come? I have made the equation. Okay, in the equation the addition sign must you have to use. Addition means we are adding, that's why. And when there is number in unbalanced number of atoms are present along with the reactants and the products are called the skeletal balance, where skeletal reaction, sorry, and where is the balanced reaction means the both side of the arrow means the reactants and the products are totally balanced from the both side, okay, equally. Now we will read about the thorough and the basic part, okay, the very important part of this chapter, that is the kinds of reaction process. We have seen that a reaction can be made as equation. Now, what type of reactions are there? Reaction is it is not in one process, it has different process. Okay, so let's go for the kinds of reaction process. Kinds of reaction process. Now come to the first kind of the reaction process, that is called the combination reaction. Combination reaction means, from here easily you can understand that we are combined, right? From the word combined, the word combination noun has came. Okay, combined is the adjective. So it means when two or more reactants are adding or combined together, then they make any particular form of the product. Here we can give the example easily. H2 plus O2 equal to H2O. Okay, and if we go, it is the skeletal balance. Look easily, because O2 and O only. So if we go for the balanced reaction, so it will come as this. So 2H2 plus O2 equal to 2H2O. It means at the both side we have completed, and combination reaction it is also doing here, because here I have used one reactant, two reactants, and it is coming as only one product. Okay, so in combination reaction mainly two or more than two reactants are used, and whereas one particular main product comes out. Got it? There is the combination reaction. Okay, now we will go for the second reaction. Okay, here one thing to say that in these kinds of reaction, normally I have done that H2 plus O2 equal to 2H2. Here I haven't mentioned that where is the temperature needed or not. Okay, the bright light is needed or not, or the or some kinds of medium, means the medium I have not mentioned, but there are very few type of reactions are there where mediums are not needed, but many type of reactions are there whereas different mediums are needed. Where it is needed much temperature, where it is needed very minimum temperature, where it is needed the icy region or the icy area, where it is needed the normal room temperature. So according to the temperature, the reaction process can be occurred. Okay, now come to the second reaction process, and the second reaction process is decomposition reaction. Now come to decomposition reaction. So just I'm rubbing this. Number 2 is decomposition reaction. In decomposition reaction, it is saying that here one product will be used, and from the product reactants will come out. Okay, it means the product will be diverge itself. When it will diverge itself, then either it will make two reactants or more than two reactants. Okay, so let's go for its own kinds. When we will read about the decomposition reactions, then we will observe that it is classifying into three different reactive parts, three different reaction parts. Okay, it means that it used or such type of reaction held in three type of different mediums. Got it? Number one, that is the, okay, we will go for first of all thermal reaction. Got it? Thermal reaction of decomposition. It is under decomposition. Got it? So 2A, thermal reaction. Thermal reaction means here heat is needed. Heat. Okay, so when we are giving the heat, that time what will be happening? Suppose I have taken the product CaCl2, means calcium chloride. Got it? Now I will provide here heat. Do you know what is the symbol of heat in equation? heat symbol is triangle shape, such a triangle shape. Okay, so instead of heat I can also use, and must give under the arrow, not over the arrow. Got it? Because heat is given from the underneath part, that's why. So heat when we will give, so it will become as Ca plus Cl2. Ca plus Cl2 means it will just divide itself or diverge itself, as CaCl2 becomes Ca calcium and chloride. So in this way it will be diverse and it will be decomposed. That's why they say there is decomposition reaction. Got it? Number 2. Number 2 is electrical reaction. Electrical reaction of decomposition. Electrical reaction decomposition means, through this name we can understand that electrical means electric has to given, or electric has to provide through the reaction. Okay, so let's go for it. We have already seen that electric, where in any medium it is used, mainly the reactants comes as the ions. Got it? Anions and cations. So let's go for the water. If we take normally the water, how it will make? Okay, so if I produce electricity in through it, if I move the electricity through it, electricity, okay, so it will come as H plus plus O minus. Okay, so look here, it is clearly, it is being seen that H plus it is cation and O minus it is anion. Means always electricity passes through any kinds of medium. That medium, if it contains any kinds of solution or any products, that products completely it will diverge itself or decompose itself to make 2 or 3 more than 3 reactants, that is plus or minus, using plus or minus. Got it? It means the cations and anions, it helps to provide or separate or sort it out. So it is the second part of the decomposition reaction, that is the electrical reaction of decomposition. Now come to number C. Number C is photolytic reaction. Photolytic reaction. Photolytic means, look, photo. What does photo mean? Photo means light, na? Photosynthesis, we have read photosynthesis, that photo means light. So here, in the presence of light, which light? Sunlight. Okay, in the presence of sunlight mainly I am telling, or if there is heavy bright light, in presence of heavy bright light also this reaction can be done. So I am taking just our ultimate source, that is the sunlight. So using sunlight, let's go for doing a reaction. So I am taking here silver chloride, as usual, AgCl2. So when I am taking silver chloride and I have taken it in the direct sunlight, suppose sunlight is falling onto it, got it? Then what it will occur? Ag plus Cl2. Ag plus Cl2. In the same way, just like this, it will also do the same type of work, that is AgCl2 will be divide or decompose itself or diverge itself, and it will make Ag and Cl2, where Ag is as a silver form it will form, and the Cl2 it will just make the another product of it or the byproduct of it. So we have already seen that thermal reaction of decomposition, electrical reaction of decomposition, and photolytic reaction of decompositions under decomposition reaction. Okay, so it means decomposition means when one particular product is diverge itself after the reaction as different reactants. Got it? Now come to the next type of the reaction. The next type of the reaction is known as displacement reaction. What? Displacement reaction. Look, displacement. At first come to the word placement. We have to take the signs in a very casual manner, and we have in a very easy way, so that we can get it and gather it easily. So first of all, come to placement. What does placement? Placement means any particular place, so it is said in the job that 100% placement will be given. It means 100% job security is there, or you must, I am 100% assuring you that you will get that particular place. That is called the placement. And displacement means interchange of the place. Okay, displacement means the interchange of the place. You will get the place, but your place could be changed. When? After the reaction. Okay, before the reaction you have one place, after the reaction maybe your or must be your place will be changed. So let's go for it. Cu plus H2SO4. What I have taken? I have taken copper and sulfuric acid. Got it? So when I have taken copper and sulfuric acid and they are in any medium, they are just reacting together. So what will happen? The sulfate, okay, H plus and SO4 minus, H2 plus and SO4 2 minus. This SO4 2 minus, this means anion will be added with this Cu2 plus. It means with cation, this anion will be added. Okay, it means its place, the sulfate's place, the sulfate ion's place will be along with the copper ion. So it will come as Cu2 plus SO4 2 minus, a neutral product. It means CuSO4 plus H2. Got it? Cation, anion, no need to give, but I have just told how it has changed itself, because we know that plus, cation or anion, they used to react together and they makes a product. Got it? Not the cation, not the anion. So that's why, whereas anion has taken out from here, so it must go for the next particular cation, that is the Cu2 plus. That's why Cu2 plus is SO4 2 minus come in contact and they become the primary or the basic product of this reaction. Okay, that's why as sulfate has changed its place, that's why it's called the displacement. Understand? Okay, now let's go for the 4-number reaction. 4-number reaction is called a double displacement. Yes, double displacement reaction. Double displacement means, displacement we understood that where one anion will be another with cation to make the product. Double displacement means here 2 reactants we will take and 2 reactants, 2 less energized particles, heavy energized to less energized. Okay, one thing to forget to say, share. Okay, in displacement reaction we have seen that Ag plus H2SO4 or Ag2SO4 plus H2 gas. So it means that here the anion part of the product of one product is adjoining with the another product as the reactants. So it means that it has made Ag2 plus Ag2SO4. Okay, and H2 it becomes alone. So it means in the displacement reaction we have seen that the less energized part, means the part that is less energized, it is change its place with the more energized part, that is the cation. Okay, so less energized and more energized, they used to exchange their products, they exchange their particles to change a new product, to become a new product, where and it happens in the double displacement reaction. Because in single displacement only one product is displacing, where double displacement the 2 products has the 2 different parts and they will be exchange itself. Okay, let's go for it. So double displacement reaction. Double displacement reaction. Okay, double displacement. So here two reactants I will take. So these 2 reactants are, suppose AgNO3 plus H2SO4. Okay, H2SO4 not. I will take here Na2SO4. Let's write again. AgNO3 plus Na2SO4. Okay, let's react. It means its less energized product will be exchange itself. It means this will go that place and that will come as this place. Got it? Okay, let's go. So if we make it, it will come as AgSO4 Ag2SO4 plus 2NaNO3. So it means, look, SO4 has came with silver and that nitrate or NaNO3 has come with sodium or Na. So it means double displacement, double product has displaced its minimum energized particles with it. Got it? So in double displacement it happens. So these all are the parts of reaction process. The another part of it, that is oxidation and reduction. Oxidation and reduction. Hope you will guys understand that what does oxidation means. Then the opposite of reduction, just like reduction, you can understand better. Oxidation means a product when it will gain the oxygen. For example, if we take copper plus H2O, okay, so what it will occur as a main product? It will occur as Cu2O, okay, or CuO plus H2. It can come as Cu2O or CuO, cupric oxide or cuprous oxide. Got it? Cuprous oxide or cupric oxide in a form it can occur, and H2 gas can be occur. So it means that from here the oxygen has taken by the copper. Got it? It means the oxygen has energized. Got it? Or oxygen has involved in the copper to make a cupric oxide or cuprous oxide. That's why it is called the oxidation. Okay, increase in taking in. If you say about our inhaling and exhaling, inhaling means we are taking oxygen. Got it? So that's why it is oxidation form in our body. Now we are taking out the carbon dioxide, means most of the oxygen also has already gone. In carbon dioxide oxygen is present, O is present in carbon dioxide. So it means that here it is also reacting as a reduction. Reduction means releasing the oxygen from the product. Okay, let's go for it. If I take this product again, CuO, so how it will form? It will form as Cu plus O2. Got it? Cu plus O2 means copper and oxygen will be divert itself. It will just separate itself. So it means it will come as reduction process. So it is oxidation process, it is reduction process. Oxidation means taking in the oxygen and reduction means releasing the oxygen. Got it? Not only this, but also different materials, different reactants are there or chemicals are there, those which play their role for doing such kinds of reaction process. Whatever we have read from the earlier, that combination process, from there each and every product used to do such kind of equations in different way, and they make the reactions and they make the new kinds of products. Got it? So this is up for today. So let's read the book at first, then watch my video. Hopefully you will understand everything, because in details I have told everything, nothing is left, I think so. So if there is any problem in understanding, then you please ask me. Got it? Thank you.